Hello everyone, and welcome back. In this video, we're going to set up our player to take damage. We're going to start with creating a global script, or a script that can be accessed from any other script in our project, no matter what scene we're in. First, let's change this folder name to Autoloads, as Autoload is a reserved keyword in Godot. Now, let's create a new script called Global. Open up the script and clear the default code. For now, we'll define a few variables. Var player equals null, var player dead equals false. These variables will help us track the state of the player, whether the player exists in the scene tree, and whether the player is currently dead. In order to be able to access this script globally, we need to add it as an auto-loaded scene. Navigate to Project Settings, and select the Globals tab. First, we will select the folder icon to the right of Path, and select the script or scene we want to be made available globally. In our case, we're selecting global.gd in our Autoloads folder. Click on the Add button all the way to the right, and now we will be able to access this file globally. Let's test it out in a random script. If we type global here in our player script, we can now access the variables we created in the global script. We're going to be utilizing groups in this tutorial. Groups in Godot let us organize and label nodes so we can easily identify and interact with them in our code. In this case, we're using a group to help our obstacle detect when it collides with the player and then trigger the appropriate response. Let's add an Area 2D node to our skier scene. Rename it to Sensor. Add a collision shape to the sensor called Sensor Shape. Add a rectangle shape and size it to fit the player sprite. I'm going to move up the sensor one place in the scene hierarchy. Let's connect the sensor signal to the player script. Leave it blank since we just need it to create a group for now. To add a group, select the Node tab and under it, the Groups tab. Click the plus button to add a new group and type in Player, then click OK. Now let's head over to our rock scene and open up the script. One small change before we get into the code. Let's rename Audio Stream Player to Hit. In our onObstacleArea entered function, if area.isInGroup player hit.play global.playerDead equals true. So now when an obstacle collides with the player, we will change the player state to dead. From there, we can change what happens next. One thing to note about changing the script in Rock is that those changes will be reflected in the tree scene because Rock is the parent scene and tree is the inherited child scene. Let's head to our player script and make some changes that will be triggered when we collide with an obstacle. At the top of the script, let's add a variable. Var death handled equals false. Now we need to create a function that will handle the player death and utilize the death handled variable. Func handle player death. In the body, type Annie.play death. Death handled equals true. Let's modify our process function to add a player dead check. We'll add if not global.player dead and then indent. Else, if not death handled, handle player death. We have set up the process function to only move the player when the player is alive, and if not, to handle the player death instead. Lastly, to prevent errors down the road, we're going to add a null check system to make sure the player still exists in the scene. This is helpful if other parts of the game try to access the player after it's been removed or died. In the ready function, we assign the player instance to a global variable. Global.player equals self. Then, in exit tree, we set it back to null when the player is removed from the scene, with global.player equals null. This way, we can safely check if global.player not equals null before trying to access the player from other scripts. We have to add the same check to our rock scene so that the obstacles will all stop once the player is dead. Add the check in the process function, if not global.player dead, and then indent. This will simulate the player coming to a halt after colliding with an object. Similarly, we want the obstacle generator to stop instancing obstacles once the player has died. Let's add the check in the timeout function, if not global.player dead, and then indent. Next, let's head to our level 1 scene, and we're going to add a script. Save it in Scripts, Levels. In the ready function, we're going to initialize the player state. Global.playerDead equals false. This ensures that the player is not dead when we restart the game, which we will get to soon. There's one more place we need to check for our player death, in the script that handles the scrolling background. But first, let's rename the canvas layer to Snow Background. Now open up the Parallax background script, and in the process function, add the check. If not, global.playerDead, and then we indent. Let's run our scene now to see what happens when the player collides with an obstacle. When we collide, the player and everything else stops, a death animation plays, and for now, that's it. It's all working, but we don't need to be able to see the obstacle generator in the scene anymore, so let's simply move it out of sight. In the inspector, let's add 32 to the Y coordinate for the obstacle generator position. Let's test the scene one more time. And now we have the base version of our game. Cool. Now we have a way to check on the player's state. In the following video, we will add some particles to our player.